Welcome everyone. In this example, I want to look at another example of a so-called back titration. In this example, we're looking specifically at one where we use a back titration to determine the purity of a sample. So we're told we have a sample of sodium carbonate and it's suspected to be contaminated with sodium chloride. We know the carbonate will react with acid, and of course the sodium chloride won't. So hence we can use the fact that we can add some acid to the solution in excess and then back titrate that acid with base to know how much sodium carbonate was there in this solution initially. We can read this systematically. So it says, to ensure complete decomposition of the carbonate, excess hydrogen chloride was added to the 0.453 gram of impure sample, namely 50 milliliter of a 2 molar hydrochloric acid solution. The reaction taking place was that after all the fizzing stopped, enough water was added to the reaction mixture to make a solution. We call this solution A, and this solution had a volume of 250 milliliter. Whereafter a 20 milliliter aliquot of this solution A was then neutralized by titration of 15.03 milliliter of a 0.116 molar sodium hydroxide solution, which follows the following reaction equation, and then we're asked to determine the percentage of the sodium chloride impurity in the original sample. Okay, so let's, I think, draw schematically or systematically where we start in this situation. So what we have is we start with typically a volumetric flask of some sort and a 250 mil volumetric flask, and we will have our little sample, so a little heaped pile of powder, and that is our sample. Our sample, we're told, is 0.453 gram, and it consists of sodium chloride and sodium carbonate. Right, that's what we're told. So we have a dry powder sample in this volumetric flask. Then to that, we then add a solution of hydrochloric acid, which we say, well, we take 15 milliliter of this solution, which has a concentration of 2 molar, and we chuck that amount into this. This then, of course, results in a reaction that takes place. And the reaction that takes place is this Na2CO3 aqueous plus 2HCl aqueous. That gives 2NaCl aqueous plus CO2 gas plus H2O liquid. Okay, so that's what happens. We have our sample, we add some very concentrated acid, but a specific amount of it in there, but what we know is that there is a base in there, the sodium carbonate, and we add enough acid in there that we know we've definitely added enough acid that all of the base that was in that sample would have reacted with it. What we then do, so once the fizzing stopped, in other words, once we know the reaction has gone to completion, we then make up this solution to the mark, meaning that we take our volumetric flask and we fill it up to 250 milliliter. and we call this solution A. So what do we do here? We basically just add water up unto 250 milliliter. So the reaction has taken place. We have those products, but we also have excess HCl. Left in that, a specific amount of moles left in that. But we've now made a specific volume of solution. We then told, right, of this, we take 20 milliliter. So take liter of this. So that's what our aliquot is. We take 20 milliliter of that, and we do a titration with that. So put that in a beaker. Here is your 20 milliliter aliquot. And what does that aliquot have? It has hydrochloric acid in it. So we have some hydrochloric acid where we have a volume, we have a number of moles, and of course a concentration that we don't know. Right, we know how much we took, but what we do is we do a titration. And this is where the so-called back titration part comes in, because we back titrated with a known amount of sodium hydroxide. So we're told we back titrated with sodium hydroxide, which is 15.03 milliliter, and the concentration of this titer is 0.116 molar. Okay, so this gives us a way to determine how many moles of hydrochloric acid was present, or what's the concentration of this 20 milliliter aliquot, which will then tell us how many moles, or from that we can then determine how many moles of hydrogen chloride was in excess, and hence then determine how many moles of sodium carbonate must have been present, and hence determine the impurity of the sodium chloride. So perhaps put it into context to say that, well, if we want to do all the calculations, the percentage sodium chloride in the sample is always calculated by taking the mass of whatever you want to calculate divided by the mass of the sample. All right? But what do we need to calculate that mass of the sample? Well, in any case, an easier way to get to this point, or that we can still get to this point, is if we determine the percentage sodium carbonate. Right? But we can say 100 minus the percentage sodium carbonate gives us the percentage sodium chloride, because the percentage sodium carbonate is going to give us is calculated from the mass sodium carbonate divided by the mass of the sample multiplied by 100. Right. So what do we need here? To get the mass of the sodium carbonate, we need the number of moles of sodium carbonate. To get the number of moles of sodium carbonate, we need the number of moles of the HCl reacted with it. I'm going to call that HCl reacted. To get the number of moles HCl reacted with it, we need to know what is the amount of HCl in total minus the number of HCl in excess. Right. And how do we get the amount of HCl in excess? We can get that from the amount of sodium hydroxide. Not directly, but we can get that from the titration information. Okay. So let's start by calculating the amount of sodium hydroxide. So that's, of course, the volume sodium hydroxide multiplied by the concentration sodium hydroxide. And this will give you a value of 1.74348 times 10 to the power minus 3 mole sodium hydroxide. Right. We know that sodium hydroxide and HCl reacts in a 1-to-1 fashion in the titration. So that means the number of moles of the HCl in the titration must be equal to this 1.743 times 10 to the power minus 3 mole HCl. Okay. But that amount of HCl is in what? That was an aliquot of 20 milliliters. So what is the concentration? Therefore, the concentration of this HCl, you'll see now why I go back to concentration first, of this titration, I'll just call it that for now, is equal to this, the number of moles of HCl in the titration divided by the volume of the aliquot. Okay, and then you should get a value of 0.08717 mole per liter. All right, this volume of the aliquot is, of course, that 20 milliliter that we calculated. Because the titration was done only against 20 milliliter of the solution A. So we know how many moles of HCl we had in 20 milliliter. So we get a concentration. Now we know what the concentration is of our aliquot. So going back to our solution A, we can say, well, we know what the concentration is, so hence the number of moles of HCl in solution A, right? Otherwise put, the number of moles of HCl in excess is then equal to the concentration of HCl in the titration multiplied by the volume of solution A. Zero seven one molar. It was at 250, so it's 250.00 times 10 to the negative 3 liter. And get a value of 0.02179 mole HCl in excess. Right, so let's quickly just follow the logic. We calculated here, we had so many HCl, but that was only in 20 milliliter. So hence we calculated what the concentration was, so that we know what the concentration is of the HCl in this solution, because we know what the volume is of solution A. It's 250 milliliter, because that will then tell us what the number of moles of HCl is that remained over after the reaction. And that is what we've calculated here. It tells us the HCl in excess. So hence, I called the thing something, HCl reacted. So therefore, the number of moles of HCl that reacted earlier, or you can even write it formally, saying reacted with the sodium carbonate is equal to the number of moles of HCl we had in total, so meaning way at the beginning, minus the number of moles of HCl we had in excess. Right, so meaning the amount that reacted plus the excess amount should give us the total amount. So hence, the amount reacted should be the total amount minus the excess amount that we measured. And the total amount is that 15.00 times 10 to the negative 3 liter multiplied by 2.000 molar minus 0.021 mole. We're left with 8.206 times 10 to the negative 3 mole HCl. All right, so now we know how much HCl reacted with the sodium carbonate. And what do we know about that reaction? Well, we know that 1 mole of sodium carbonate reacts with 2 mole hydrochloric acid. We want to know how many moles of sodium carbonate, and we have 8.20 times 10 to the minus 3 mole HCl this side. So you can go and do the calculation. So on this side, the formal way of writing this, or the big name for this is the name of NaCO3 in this sample. And you should get a number of 4.103 times 10 to the negative 3 mole. CO3 in the sample. All right, and from that we can determine the mass. So of course, the number of moles times the molar mass. The molar mass is 105.99 gram per mole. So let's just say number of moles multiplied by the molar mass. Molar mass is 105.99. You get a number of 0.4349 and so forth gram sodium carbonate, and hence we can calculate the mass percentage of the sodium carbonate in the sample by taking what we did up here. So we said mass percentage of sodium carbonate is going to be mass of sodium carbonate over mass of sample. right? You know what the mass of the sample is. You should get a value of 96.005%, and dot dot dot, because that's not yet our final answer. So therefore, the percentage of the sodium chloride is just going to be the other part. So percentage of sodium chloride in sample is equal to 100% minus the percentage sodium carbonate, and is rounded to three significant figures, 3.99%. Okay, so that's in essence it. It's just always important to remind yourself where is what's going, what the volumes are, and what fraction of what you're looking at where. And I think the drawing of where what goes helps significantly. But whatever works for you, and of course, if it helps writing down the explicit names for any symbols, I think that's also important. All right. Thank you for watching, and I'll see you in the next video.